All right, so we'll first start with worksheet 2, which is theory, and then we'll come back to worksheet 1, which is MCQs. Because I think MCQs are a little tough, so it's always a good idea to first brush up on your theory part. Alkenes and alkenes both react with bromine. Okay. Now, there is a lot difference in how they react, right? Alkenes, आपको पता है कि they do free radical substitution, and alkenes, they can do free radical substitution if the condition is right. What do we need to give them to do free radical substitution? In what condition will free radical substitution happen? When chlorine will break down? When you have ultraviolet light, it will form chlorine radicals. So tab substitution hogi. But if that is not available, alkenes के जो pi electrons होते हैं ना, they will react, and those pi electrons will do electrophilic addition with bromine. तो दो different reactions हैं, दोनों alkenes कर रहे हैं. एक में the idea of radical is important क्योंकि ultraviolet light से chlorine के radical बनते हैं, और दूसरे में the sorry, that's my dog. In the other one, you have the pi electrons, which are very reactive, which are rich in electrons, वो react करते हैं. Explain how and why bromine can be used to distinguish between alkenes. बहुत simple सी बात है. अगर alkane होगा तो वो pi electrons नहीं है उसमें, तो वो तो react नहीं कर सकता pi electrons वाला. So we can say that the color of aqueous bromine stays the same. Okay. So Br2 remains orange or red brown even with alkanes, but goes colorless with alkenes. Kyun? To make halogen alkanes, या haloalkanes भी बोलते हैं उसको, या alkyl halides भी बोलते हैं उसको. The reaction of ethane with bromine forms a mixture of products. Ethane है, ठीक है? That means free radical substitution है. So क्या चाहिए हमें? Ultraviolet light. Give the full name of mechanism. Free radical substitution. अच्छा, free radical substitution में 3 steps थे. Initiation, propagation, termination. याद करने के लिए, the simplest way to understand is that initiation is when you create radicals. Termination is when you finish radicals. No radicals left over in termination. Initiation, the radicals are initiated, they're starting out. तो यहाँ पे देखते हैं termination में क्या होएगा? You want to create a hydrocarbon. Hydrocarbon चाहिए आपको. इसका मतलब है कि जो आपके पास radicals होंगे उनका रिएक्शन करवाएंगे आप. क्यों? टर्मिनेशन है. And radicals should make hydrocarbons. So think about it. What radical can I make from ethane? Let's see. Ethane is C2H6. If you react it with chlorine radical, then chlorine can make HCl from it. And now, what if you remove one hydrogen from C2H6? You are left with C2H5. So ये radical है. अब वो कह रहे हैं कि एक radical से दूसरे radical का reaction कराओ ताकि एक हाइड्रोकार्बन बने. अब जरा देखते हैं, इस radical का इस radical से reaction करवाएंगे तो हमें मिलेगा halogen alkane because C2H5Cl will be formed. If we react chlorine with chlorine radical, it will form chlorine molecule. And if we react this radical with itself, or we get two of these, they will join together and they will make C4H10, which is a hydrocarbon. So clearly we have done it. And the best way to solve question on free radical substitution, मैंने आपको बताया था उस दिन, list बनाएं. On one side you read the molecules and on one side you list the radicals. और बस उसका reaction करवाते जाएं. ये radical इससे collide करेगा तो ये दोनों बनेंगे. और ये radicals create कर रहा है. Similarly, this can collide with this to make new radicals, ठीक है? और new molecules, like अगर इसका इससे collision होगी तो क्या बनेगा? C2H5Cl and then as well as a chlorine radical. So आप list बनाते जाओ, आपको नए नए radicals या नए नए products मिलते जाएंगे. Initiation में सिर्फ radical बनता है, termination में सिर्फ molecule बनता है, और propagation में दोनों steps होते हैं. एक रेडिकल और एक मॉलिक्यूल रिएक्ट करके एक रेडिकल और एक मॉलिक्यूल ही बनाते हैं. आगे क्वेश्चन आएंगे. Give the equation for one propagation step involving the formation of dibromoethane from bromoethane. ठीक है, bromoethane से start करते हैं. C2H5Br. This is a molecule that we have. ठीक है, तो मतलब यहाँ पे क्लोरीन नहीं है, ब्रोमीन रेडिकल की बात कर रहा है वो. सो ब्रोमीन मॉलिक्यूल है, C2H5Br है, Br. Now pay attention people. What can we get here? I have this and I want to end up with C2H4Br2. How do I do that? First of all, I cannot do it right away in one step. Propagation is always two steps here. तो अगर मैं यहां से स्टार्ट कर रहा हूं तो मैं डायरेक्टली ये नहीं बना सकता. मैं पहले इसको एक रेडिकल से कोलाइड करवाऊंगा. इन दोनों का जब रिएक्शन होगा, व्हाट विल आई गेट? आई विल गेट HBr by removing this hydrogen here, and now I have C2H4Br radical. C2H4Br radical. Of course, now the next step is this collides with this to make dibromoethane. Okay? So this is one propagation step. Of course, the second propagation step is there, जिससे मुझे मॉलिक्यूल बनेगा जो वो बनाना चाहता हूँ.
Sir?
Yeah.
So we could also write C2H4Br radical plus Br2. वो भी ठीक हो जाएगा.
Yes, of course, because they asked us to write just one step. Another method that we can do is that, okay, let's end up with what we wanted to make. C2H4Br2. मुझे ये बनाना है. तो किस रेडिकल से बनाया होगा? इस रेडिकल से बनाया होगा. कैसे? ब्रोमीन मॉलिक्यूल से रिएक्ट करवाकर एंड ब्रोमीन रेडिकल जनरेट करवाकर. So we can write any one of these and that will be the correct answer. You just have to identify that either you can start with bromoethane or you can end with dibromoethane. दोनों एक reaction में नहीं हो सकते. The reaction of ethene with bromine forms a single product because it's addition, right? But which addition? It is electrophilic addition. I think there's only one L in electrophilic. Fair. You don't lose marks because of this. All right, now let's get to the mechanism. Okay, so first of all, you have to understand, मैंने आपको बताया था कि आपने देखना है कि electrons कहाँ हैं, charges कहाँ हैं. That is how any reaction starts. So over here I have pi electrons. So there's going to be a rich negative charge here. And because of that negative charge, this is going to feel a positive charge. And the moment there is a slightly positive or negative charge or a mismatch of charge, the electrons are rushing and going to attack it. और जैसे ही electrons आएंगे तो ये electrons किधर जाएंगे? दूर. Just like grade 10 electrostatics. एक साइड से electrons आ रहे हैं तो दूसरे वाले electrons repel हो जाएंगे. All right, what do we have here now? So the double bond breaks. One of them joins with Br. The Br other one makes a negative charge. Do not forget to put the lone pair there. ये कहां से है? ये दोनों इलेक्ट्रॉन्स इसको मिल गए और इस पर पॉजिटिव चार्ज आ जाएगा, कार्बोकैटायन बन जाएगा. This will attack this. Remember to show the curly arrow from the lone pair. Wherever electrons are, curly arrows tell us how they move. And that is how we end up with this compound. इसमें 4 marks हैं, curly arrows के marks हैं, कार्बोकैटायन के marks हैं, partial charges के marks हैं, and lone pair draw करने के marks हैं.
And sir, it's not like specific, like for the specific carbon, it doesn't really matter which bromine it's attached to, right?
Yes, it doesn't matter because first of all, we are using both the atoms are the same, and secondly, the carbons are both symmetrical. It doesn't matter in this particular question. All right. Okay, so we have here, what is its name? Let's see. I found that students usually prefer drawing the displayed formula first तो बना लेते हैं. कार्बन है, उसके पास दो ब्रांचेस हैं, CH3 CH3 double bond CH3 CH3. Now first of all, before you name it, you have to identify the long chain. So start anywhere, let's say 1 2 3 4. So the long chain is bute. It has double bond, so butene, and the double bond is on the second carbon, so butene. So butene. Then there's a branch here and there's a branch here on the second and third carbon. So 2,3 dimethyl butene. And there you go. That's the answer. Draw the skeletal formula. Iska nahi, of the organic product with cold dilute acidified manganate. We know that when cold dilute acidified manganate is reacted with it oxidizes it. And this is mild oxidation. It produces diol. So both the carbons will get OH. So the double bond is going to break and you're going to get OH here and OH here. So let's do it. I have, what is it? This is butane. So 1, 2, 3, 4. Okay. On the second one, I have OH. And I also have this, the methyl group. And clearly you have this. The compound is made. It's a skeletal formula. This one tells me this is the main chain. This is a methyl group. This is a methyl group. This is an OH. This is an OH. Does everybody understand that there's no chiral center here? Name the organic product of the reaction with hot concentrated acidified manganate. Let's see. If it was hot concentrated, so क्या होता? ये double bond ऐसे थी ना? यहाँ पे CH3 था, CH3, all of that. So first of all, the double bond would have broken, पूरे के पूरी तरह. And then every carbon in here on each side would have oxidized to propanone. And that is what we have to identify. So ये हमारा rough work है सारा. So make sure you do it in pencil so you can erase it later on. Okay. So the answer would be propanone. Draw the structure of part or molecule of the addition polymer formed from this compound. Polymer बनाने में हमने देखा था. It was in the notes. I did not specifically address it क्योंकि ये O levels वाली बातें हैं. Make sure that you review the notes again if you don't. If you haven't. सबसे पहले polymer बनाते हुए हम standard form में लेके आते हैं उसको. इस तरह ये standard form है. तो हमारे पास CH3 है हर जगह पर तो हम CH3 लिख देते हैं. अब polymer बनाते हुए what you have to do is you have to follow the RCJ method. Remove, copy, join. What do you remove? You remove the double bond. What do you copy? You copy whatever is left. So उसने 3 दफा बोला है ना तो हम 3 copies बनाएंगे. And what do you join? You join these with each other. And there you go. All right. Now here's the thing. Do you have to draw the brackets? You shouldn't, because they said draw the part of molecule. But you won't lose marks if you do. So you can do without them. आप ऐसे ही छोड़ दो तो भी ठीक है. Or you can put the brackets if you feel like. I hope it's clear to everybody. All right. What do we have here? We have a slightly different molecule from the last one. This is not butane. It's actually propene with a branch here. So 3 carbons make propene and the branch is methyl. So this is going to be 2-methyl propene. Interestingly, मुझे इसको prop 1 बोलने की जरूरत नहीं है क्योंकि कभी भी 1 आ जाए तो हम नहीं लिखते. And secondly, in this case, कोई confusion हो ही नहीं सकती. इधर से होगा तो भी 1 पे, उधर से होगा तो भी 1 पे. Doesn't matter. All right, now let's do the mechanism. Again, for mechanism, सबसे पहला step है identifying negative charge कहाँ पे, positive charge कहाँ. ये pi electrons हैं, तो negative charge में rich हैं. इनके होने की वजह से this will get a positive slightly charged and this is slightly negative. वैसे भी ये polar bond है. Now the electrons attack the positive and the other electrons run away. Okay. I have the lone pair here and I also have this thing here. Now it's important to specify in this particular case कि hydrogen किधर गया, because the product is shown to you. This product में you can see that the first carbon from the right that has hydrogen. So हमने वहां पे hydrogen बनाना है. ठीक है? If you do it elsewhere, you will lose marks. And this also specifies that the positive charge will be on this carbon. So now this is going to attack this. Yes.
So wasn't there a rule कि जिस कार्बन के साथ ज्यादा हाइड्रोजन होंगे हम उसके साथ लगाएंगे हाइड्रोजन?
Yes, that is called Markovnikov's rule. But एक चीज का ख्याल रखें. Markovnikov's rule tells you the major product. कि majority ये वाला product बनेगा. इसका ये मतलब नहीं है कि दूसरे वाला बन नहीं सकता. बनेगा, कम quantity में बनेगा, but the other isomer will be made.
Sir, so if you follow the rule, the first वाला जो double bond वाला carbon है, like from the left side, उसके ऊपर hydrogen आता.
No, no, no. If you follow the rule, you put it on the carbon with more hydrogen. क्योंकि देखें, इस कार्बन के साथ डायरेक्टली कोई हाइड्रोजन नहीं. This one has two, and Markovnikov's rule only talks about that direct hydrogens. This is not NMR. NMR में हम साइड वाले हाइड्रोजन्स को देखते हैं. ये वो नहीं है. Explain fully why 2-bromomethyl propane is this compound, is the major product while only relatively small amounts of 1-bromomethyl propane are produced. असल सवाल वो आपसे ये पूछ रहा है कि बताएं जी ये कार्बोकैटायन इधर क्यों बना है, इस पे क्यों नहीं बना. And for that we have to talk about the stability of carbocation, which comes from the inductive effect of the alkyl groups attached. Okay, so we will say that obviously हमारे पास choice क्या है, या कार्बोकैटायन इधर बनता या कार्बोकैटायन इधर बनता. ये कार्बोकैटायन कौन सा है? प्राइमरी, सेकेंडरी, टर्शियरी, which one is it?
Secondary.
It is tertiary because
Tertiary.
1, 2 and 3 carbons attached, which means it has inductive effect from 3 sides. So we'll say that tertiary carbocation is more stable. And whenever you're comparing, you must talk about the other thing as well. Then what is this carbocation? Primary, secondary, tertiary?
Primary, sir.
Primary.
Primary. Very good. Then primary carbocation. Now give a reason. क्यों भाई? क्यों है ऐसा? Due to positive inductive effect of alkyl groups attached. What exactly do these alkyl groups do? They provide electrons, so they basically reduce the strength of this charge. So उसकी वजह से वो charge वहां पड़ा रहता है, उसको stability रहती है. Stability is all about staying what you are, being what you are. This carbon having a positive charge does not make it very reactive because ये electrons provide कर देते हैं. इस पे अगर कार्बोकैटायन बनेगा ना तो इसको इलेक्ट्रॉन प्रोवाइड करने वाला सिर्फ ये एक ग्रुप है, तो वो उतने स्ट्रांगली या उतने पॉजिटिव चार्ज को रिड्यूस नहीं करेगा, उतने इलेक्ट्रॉन्स देगा नहीं कि वो स्टेबल फील करे. इसकी वजह से इट इज नॉट गोइंग टू लाइक मेक अ कार्बोकैटायन फॉर लॉन्ग. ऑलराइट, But 1 in reacts with steam as shown from a mixture. Okay, ये दो मिक्सचर बना देता है. S can be oxidized further, ठीक है, NS and U both react with alkaline aqueous iodine. We have not studied alkaline iodine wala reaction. It's called iodoform reaction. We will come to it after we study carbonyls, so don't worry about it. Now let's look at the other one. What's happening here? We are adding steam to it. This reaction is called hydrolysis or hydration, और यही क्वेश्चन में उसने पूछा है, तो आप हाइड्रोलिसिस या हाइड्रेशन बोल सकते हो इसको. State what can be deduced about the structure of S from its reaction. अच्छा, अब अभी based on what we have studied so far, the only thing that we can infer is that by adding steam to an alkene, we will be getting alcohol. That's all we can infer at the moment. But once you study this reaction aqueous iodine wala, you will have more information. Explain why S is the major product. Again, major product कोई भी चीज क्यों होती है? Carbocation की stability because of attached in positive inductive effect of alkyl groups attached. That is what we will talk about. Okay. I'm going to tell you that the formula of the other thing is C4H9OH. Can you draw two isomers of this? Yeah, it's correct. I'll show you. You have C4H9. So पहले तो चार का skeletal बना लेते हैं. 1, 2, 3, 4. And now OH is going to be there. So OH first carbon पे आ सकते हैं या second carbon पे आ सकते हैं. Of course, right now, based on some extra information, I can tell you कि T इधर होगा और ये इधर होगा. But as far as you guys are concerned at the moment, this is fine. You should be able to come up with these two at least. We'll leave this question. All right, let's look at this question. The hydrocarbon A and B are both unbranched. Yes.
In the previous isomer wala question, can't we change functional OH group, OH की like position?
Because we know that they're both made by hydrolysis of alkene, we know that they have to be alcohol.
I'm sorry, my question. I confused it. It was कि हम branch को like वो 3 carbon वाली नहीं कर सकते, and then.
अच्छा, वो हम तब कर सकते होते अगर हमें ये ना पता हो कि ये कैसा है. उसने बताया है कि ब्यूट 1ene है. That means कि 4 की चेन है. हाँ, अगर वो हमें जनरल क्वेश्चन दे देता तो तब हम 3 वाली चेन बना सकते थे.
Got it, thank you.
You're welcome. All right. The hydrocarbons A and B are both unbranched. A does not decolorize bromine. That means no carbon-carbon double bond. B decolorizes bromine, so that is C double bond C. And then, of course, it shows geometrical isomers. That is cis-trans isomerism. ठीक है? So इसका मतलब है कि C4H10 is butane. ये ब्यूटेन हो गया, 4 की चेन बना ली हमने. एंड दूसरा उसने हमें कहा नहीं है, लेकिन हम बना सकते हैं कि दिस वन इज गोना बी दिस. एंड कैन एनीबॉडी आइडेंटिफाई कि ये जो मैंने आइसोमर बनाया है इसका, इज दिस सिस और इज दिस ट्रांस?
Sir, trans.
This is trans, shabash. This is trans. And if I wanted to draw cis, I will simply do this. So that will be the cis isomer. All right. The hydrocarbon C4H10 has a branched isomer. Explain why unbranched A has a higher boiling point than its branched isomer. Now, of course, it has to do with two factors. One is the surface area of the molecule, which is better represented as the term packing. Okay? Use the idea that unbranched hydrocarbons pack more closely, or they have higher surface area, जिसकी वजह से they have stronger intermolecular forces. So unbranched A has better packing, or packs better, I can say packs better, or you can also say that it has higher surface area. So has stronger intermolecular force of attraction. You can also say van der Waals forces. Give the structure formula of B. B क्या है इसका? B कहाँ है? अच्छा, B is this thing. So B is gonna be CH3 CH3. Basically, B is the alkene with 4 carbons. One more thing. Whenever you draw the structural formula, always show the double bond. ये आपके क्वेश्चन करने में भी आपको आसानी देगा. So double bond show करा दिया करें. Explain why it shows geometrical isomers. Now, उसमें दो बातें करनी है आपने. Geometrical isomers क्यों होते हैं? First of all, there is limited rotation of the double bond, which is the reason geometric isomers exist. Then you identify one common group on each carbon. जैसे मैं देख सकता हूं कि इस कार्बन के साथ ये मिथाइल ग्रुप है और इस कार्बन के साथ ये मिथाइल ग्रुप है. You can also talk about hydrogen, but methyl is a better thing, I would say. मतलब कोई फर्क नहीं पड़ता है. So you can say that first of all, the carbon-carbon double bond has limited rotation. That's one important point. जिसकी वजह से cis trans isomers होते हैं. And secondly, that the CH3 groups can be on same side of carbon-carbon double bond or opposite side. And that is how you get cis trans isomers. Same side is cis and opposite side is trans. Well, this is cis and this is trans. Draw the mechanism of reaction of B. Again, B क्या है? B is the this compound. मतलब मैंने ये वाला बना दिया, आप कोई और भी बना सकते हो, इससे फर्क नहीं पड़ता है. मतलब you could have simply moved this here. Trans भी हो सकता था. As such, it doesn't make a difference in this particular compound. And we have to show the mechanism. So सबसे पहले we bring the bromine close to it. Bromine close to the pi electrons gets partial charges. So you get +2, slightly negative. And then the electrons attack it because of the positive charge. When electrons come, तो ये electron दूर जाएंगे. अब क्या होगा? Carbocation बनना. Can anybody tell me किस carbon पे carbocation बनने का ज़्यादा chance है? Left or right?
So shouldn't it be the same? Like it should be.
It is the same. Very good round. It is the same because they're both secondary, they both have equal inductive effect. So it can be either, so I can just put it here. अब इसको bromine मिल जाएगा और वहां पर bromine का lone pair आ जाएगा. Make sure you draw the lone pair, don't forget it. And now attack from the lone pair and we end up with CH3, CH3, Br, Br. बन गया. Explain the origin of dipole in this mechanism. कहाँ से आ रहा है ये dipole? The dipole was because of the pi electrons. So we'll say these are the electrons in pi bond induce a dipole on bromine. A, B, C all have formula. They all decolorize bromine. मतलब इन सब में ये है. And are structural isomers of each other. Okay. State the name of the process by which A, B, and C could be obtained. You have a much larger molecule.
Cracking?
Cracking, shabash. So this is cracking, yes. Okay, so we have to make 3 isomers of this. Of course, 2 तो बन जाएंगे cis trans और एक branch isomer बन सकता है. मतलब पहले मैं 4 की chain बना लेता हूँ. 1, 2, 3, 4. डबल बॉन्ड इधर मूव कर देते हैं और दूसरे वाले में डबल बॉन्ड मिडिल में मूव कर देते हैं. रिमेंबर, ये जो मैं बना रहा हूँ ये डिस्प्लेड फॉर्मूला है. ये मेरा फाइनल आंसर नहीं होगा, ये मेरा रफ वर्क है. ठीक है, अब मैं इसको कैसे बनाऊंगा? अच्छा नहीं, स्ट्रक्चरल आइसोमर्स हैं, ऑप्टिकल आइसोमर्स नहीं है. स्टेरियो आइसोमर्स नहीं है, जिसका मतलब है कि ये ब्रांच ही हो सकती है अगले वाली. So I can have this thing. Why can't I have cis trans isomers? Because ये structural isomer है, they're not stereo isomers. ठीक है, so this one's gonna be okay. So this is my structural formula. How do I start? I draw from one side, start here. हर कार्बन की बात करता जाऊंगा. CH2 double bond CH CH2 CH3. This is CH3 CH double bond CH CH3 CH3 in the branch C and then double bond and then CH2. And yeah, we've done it. Only A shows geometrical isomerism. Okay, that is this one. Explain the meaning of geometrical isomerism. Geometrical isomerism are molecules with same molecular and structural formula, but different arrangement in space. लेकिन ये तो स्टेरियो आइसोमरिज्म की बात है. How is geometrical isomerism connected with this? Due to carbon carbon double bond. अगर आप खाली यहां तक लिखते हो ना, आपको 1 मार्क मिलेगा, बिकॉज आपने स्टेरियो आइसोमर्स की डेफिनेशन दी है. यही क्वेश्चन एक और तरह से भी आता है. दे कैन आस्क यू एक्सप्लेन द मीनिंग ऑफ द टर्म ऑप्टिकल आइसोमर्स. सो यहां तक बात सारी सेम होगी, बट देन यू विल से ड्यू टू कायरल कार्बन, बिकॉज दैट इज व्हाट कॉजेज द optical isomerism, and carbon carbon double bond is what causes geometrical isomerism because of its limited rotation. Draw the displayed formula of A and use it to show the mechanism of reaction of A with HBr. Okay, that's pretty straightforward. A क्या है? कोई उसने बताया नहीं. ठीक है, तो you can pick any one. Okay, let me pick the one that we draw. So
Sure.
ये था. Yeah.
Since it says कि A is geometrical, तो हम वो double bond वाला जो हमने बनाया वो वाला नहीं लेंगे.
Oh, A shows geometric. Sorry, I forgot. So ये होना चाहिए. Thank you. Okay, so first of all, we have HBr. Now remember, you have a polar molecule. That means H is the one that's going to come here because of its slightly positive charge that's already there. The pi electrons attack it, and these electrons run away. We get carbocation on one. Again, this is symmetric molecule. कोई फर्क नहीं पड़ता है, तो I can just put it here. Sorry, this is CH3. Br with the lone pair. The lone pair attacks it, and we are done. There you go. All right, now let's do some MCQs.
Sir, we could make this on the other carbon as well, right?
Of course,
Br.
we could. Yeah, we could. चलो जी, यहीं से start कर लेता हूँ. Which intermediate ion forms in the greatest amount during the addition of HBr to propene? ठीक है, अभी हमने addition का reaction का mechanism लिखा था. ठीक है, so उसमें obviously it's the one that has the greatest inductive effect. Which one is it? Propene है. Propene में दो ही हो सकते हैं. एक हो सकता है यहां पर, ठीक है, और एक हो सकता है कि यहां पर पॉजिटिव चार्ज बन जाए. तो which one do you think is the more possible one? Yeah, major product.
Sir, A.
Yeah, A. Yes, that's right. This one. क्यों?
So it has more carbons attached to it, though greater stability.
You won't get a mark if you write that.
And also there's a carbocation.
The question is, why does this carbocation form for the major product? 2 mark का question है. कैसे लिखेंगे?
So it's a secondary carbocation, therefore it's stable. And because of that, there is a positive inductive effect because of the alkyl groups attached. Therefore, there's a higher likelihood of it to form there, like on the second carbon.
Very good. Just add one more thing, that when you said it's the more stable one, write about the third, that the other one is primary. Just mention that, but otherwise, very good answer. All right, 4 students, W, X, and Y, and Z, made the following statement of alkenes and alkenes. Okay, W says bromine reacts with alkanes by electrophilic substitution. क्या बोल रहा है ये बंदा? Bromine reacts with alkanes by free radical substitution. So this statement is clearly off. तो ये गलत हो गया. Bromine reacts with alkenes by free radical substitution mechanism होता है. Free radical addition कोई चीज नहीं होती यहाँ पे. So ये wrong हो गया. Alkenes can be oxidized by acidified manganate ions. Of course, we saw it. If it is cold, it makes diol. If it is hot, it breaks the bond. Alkenes are formed from alkenes by cracking. That is also correct. So clearly, yeah, ये वाला ठीक है. Alkene X has molecular formula C4H10. X reacts with Cl2 in the presence of sunlight. So free radical substitution हो रही है. To produce only 2 different monochloroalkanes, C4H9Cl. Obviously, क्यों? क्योंकि हमारे पास ऐसे है ना. So either the first carbon can get chlorine. अब वो ये और ये 6 sites identical हैं. कहीं पे भी आ जाए तो वो एक ही बात है. And ये 4 sites be equal, because in that case you'll get chlorine on the second carbon. So that's why you're getting 2 isomers. Both of them produce the same alkene Y. Of course, how do they make alkene? Does anybody recall the reaction name? अगर यहाँ पे chlorine है, for example, how will I get alkene from here? Through a reaction called elimination. By removing HCl. और वो HCl कैसे remove होएगा? कि chlorine यहाँ से और hydrogen यहाँ से. They will give us a double bond. Both of these monochloroalkanes produce the same alkene Y. अब Y कैसे बना है? Y is basically कि मैंने पहले ये बनाया था और अब यहाँ पे double bond बन गई. ये Y है. When they are treated with hot ethanolic KOH. अच्छा जी. अब ethanolic KOH क्या करते हैं? Elimination करता है, जो अभी बताया था आपको. अच्छा जी. What is produced when Y, ये जो बना है, is reacted with hot concentrated acidified KMnO4. Hot concentrated at double bond को तोड़ेगा. This bond will break. This carbon is going to form carbon dioxide. The 2 hydrogens here, they're going to make water. And this whole thing, because it is secondary carbon, उसके पास एक hydrogen है, that hydrogen will form OH, and this carbon will form double bond with this. तो ये हमारे पास propanoic acid बनेगा. So let's see, what is our option? No, wait. Okay, I made a mistake. Sorry, guys. This double bond won't be formed. Actually, when this chlorine goes away, major product होगा ये. और इस major product की वजह से double bond बनेगी यहाँ. और उस वजह से क्या होगा? कीटोन बनेगा, है ना? Yup, ये bond टूटेगी. We will get ethanoic acid. No, not ethanoic acid. We will get propanone. Because if they are producing the same alkene, then we have made mistake with how C4H10 is made. क्योंकि देखें, अगर C4H10 ऐसे होता है ना, तो then we will not get same alkene Y. क्योंकि यहां पे अगर क्लोरीन लगा होगा तो हमारे पास दो ऑप्शन है. Either we get the double bond here or we get the double bond on one side as I made it earlier. Is everybody with me here? Why this is not going to work? Because they said they produce the same alkene. अब देखते हैं कि सेम
Sir,
alkene
can you
बना.
explain this one more time, please?
हाँ मैं करने लगूँ. बेसिकली वो कह रहे हैं कि alkane X has molecular formula C4H10. C4H10 के मेरे पास ना दो आइसोमर्स बना सकता हूँ मैं. एक आइसोमर बनेगा ये, दूसरा आइसोमर बनेगा ब्रांच वाला. That I can make this. Clear so far? ये मेरे X के दो आइसोमर्स हैं. X reacts with chlorine to produce only two different monochloroalkanes. Okay, let's see. When this reacts with chlorine, it can produce chlorine here, like on the first carbon, or it can produce chlorine on the second carbon. ठीक है, बाकी सारे हाइड्रोजन होंगे. तो मतलब ये हुआ तो ये दो बनाएगा, और अगर ये हुआ तो क्या करेगा, ये इससे भी दो बनेंगे. One option is that the carbon in the middle gets a chlorine, and the other option is that the carbon on the side, यानी कि वो ये साइड हो सकती है, वो वाली साइड हो सकती है, that gets a chlorine. With me everybody? आगे क्या कह रहा है वो? Both of these monochloroalkenes produce the same alkene Y. यहां पर we made a mistake. I'm sorry, I made a mistake. वो कह रहे हैं कि when I do elimination on this, I only get one organic compound. अब बात ये कि जरा ट्राई करते हैं. If I do elimination on this, तो मुझे मिलता है, एलिमिनेशन क्या होती है, यू रिमूव H and Cl and you get double bond. तो I can remove this H and I can remove this Cl and I will get double bond here, or I can remove this Cl and I can remove this H, or I can remove this Cl and I can remove this H. सेम एल्कीन वाली काम खत्म हो गया ना, इम्पॉसिबल हो गया. देयर इज अ डिफरेंट पॉसिबिलिटी देयर. मतलब जब इसकी एलिमिनेशन करेंगे दो आइसोमर्स आएंगे, और उसने कहा कि एक ही आइसोमर आना चाहिए. इसका मतलब ये पूरा सेटअप गलत है, ये नहीं हो सकता. अच्छा, अब इधर आ जाते हैं. इन दिस वन, if I remove this chlorine and this hydrogen, so what do I get? Sorry, I get, ये था ना, यहां पे डबल बॉन्ड बन जाती. And if I remove this chlorine and this H, again I get the same thing out. So clearly my X is this, because this is the only one that is giving us the same Y, same alkene Y, no matter where the chlorine gets attached. And this compound, this is Y. अब वो कह रहे हैं इसको मैंने ऑक्सीडाइज करना है. ठीक है, करे. जब इसको ऑक्सीडाइज करेगा तो ये बॉन्ड टूटेगी, और जब ये बॉन्ड टूटेगी तो this carbon will make carbon dioxide, the two hydrogens will make water, और ये जो चीज बची है ना, this will make ketone. Very good question. So इस वजह से हमारा आंसर होगा. The other one would have given us two different isomers. एक प्रोपेनोइक एसिड बनना और एक में प्रोपेनोन बनता. सिंगल प्रोडक्ट नहीं बन रहा था. Clear, everyone? Hydrogen bromide can be added to T to give compound U. Okay, so T is this. It's a cyclic compound. And hydrogen bromide is added. Of course, the pi electrons here, they have attacked it, done the electrophilic addition, which is the step 1, to form this. Step 2, make क्या हुआ कि this bromine has been displaced by OH. We will talk about this reaction in detail in the next chapter. अभी के लिए ये step 2 को मैं discuss नहीं कर रहा. Step 1 को देखते हैं. Does anybody any statement work on that? All the atoms in a molecule of compound T lie in the same plane. Same plane. That's not the case because that's not possible. The moment you get sp3 hybridization, say goodbye to same plane. Okay, तो ये sp3 है, ये sp3 है, sp3 ये नहीं कर सकते, ये भी sp3 है, ये भी नहीं कर सकते. sp3 का मुझे कैसे पता चलेगा? 4 single bonds. Okay, compound V contains only one chiral center. ये तो हम देख के बता सकते हैं. Compound V में chiral center देखते हैं कितने हैं. पहले मैं chicken feed बना लेता हूँ. This is hydrogen. Okay, this is hydrogen, hydrogen, hydrogen. Okay. Chiral center मेरे पास एक ही है और एक ही है. So obviously ये बात गलत होगी. Step 1 is electrophilic addition. ये बात ठीक है. Step 2 is nucleophilic substitution. This is correct, but again, you are not expected to know at this point in time. So yeah, Y and Z are both correct. All right, this is the last question for today. Which statement about polychloroethene is correct? The polymer can be cracked to produce chlorinated alkenes. ये बात ठीक है, किसी भी polymer को आप तोड़ के smaller alkenes बना सकते हैं. And this one is true. The polymer has harmless commercial product. No, it has chlorine. It produces HCl when it burns. It is readily biodegradable. All addition polymers are notorious when it comes to biodegradability. So that's not the case. The repeat unit of the polymer has an MR of 97. The repeat unit is chloroethane. Not chloroethane, it's basically the single bond with this. So वो तो obviously points में होगा, chlorine है, so that's not possible. All right,